By the way, in case you haven't figured it out, there is no undo at the command line. And so if you accidentally redirect into something, something bad can happen. In general, I recommend running as just your normal user. You're not running in the context of the root user or your administrative user, because it's harder for you to accidentally damage the whole system as opposed to just damaging your own files. But, with this, the output redirector, if there's already a file there, it will be overwritten. So if you meant to append with the double greater than as opposed to just overwrite, these very subtle differences can make a huge difference, and you can accidentally overwrite things. So just know that there's no undo from the command line. So, and shell expansion is its own topic. I mean, a shell expansion and the bash shell and all of the stuff that goes with that could be its own book. In fact, I think O'Reilly has written several books on bash. There's a pretty good book I can recommend, the Bash Pocket Reference from O'Reilly. There's a lot of good information there about bash and how it works, and if that's something that you're more interested in, then you should definitely check out the book. For now, we've got to move on to searching and finding and searching things. So maybe we want to go hunting for our copy of Moby Dick. We did some work on it. I don't remember what directory we put it in. I mean, I do, but it's fine. We do find dot dash name Moby. Nothing. Oh, star. Now wait a minute. How does what's going on here? No, it's cool. The shell is not expanding the star. Remember the subtle difference that I showed you when we did a ls-star and it couldn't find it, and so then we have the name Moby, and so the shell expanded it. Okay, so what if I do touch Moby foo with a lot of O's? Find dot dash name Moby foo. You see what just happened there? Got ourselves in a little bit of trouble, didn't we? Do you know why? There's a little mini exercise, a mini activity. You should be able to explain to me why that just happened. Oh, I'm hearing a lot of terrible answers, but also a few correct ones. I can hear you through your TV. Is it? Have we graduated to full Twilight Zone? No, it's cool. So what happened here is Moby Star was expanded by the shell. It thinks that you're wanting to expand this, and so it sees a file in the current directory named Moby foo, and so this command ends up becoming find dot dash name Moby foo, and so find finds it. And so remember our first command we ran, find name Moby, didn't find anything, but I did find name Moby star, and so it found it here. We literally ran the exact same command and it did not find it, and that is because the shell expanded Moby star into Moby foo, and so find found Moby foo. But we actually wanted edited works moby10b.txt, because remember the original premise was I said I didn't remember where we put it. I did, but it's fine. So we've got, edited works in here and, Moby, and it found Moby star. And this is because Moby star, because it could not be expanded, was passed as Moby star to find, and then find found it with the wildcard because find supports that. So what's the workaround? What do you do? Well, quotation marks. Quotation marks. Now, strictly speaking, I think I would go for the single quotes instead of the double quotes, because there is a subtle difference between single and double quotes. But I was very surprised to learn when I was putting this lesson together that on this system, single or double quotes to find works fine. Perhaps another example will work. So we have environment variables. This is not to get too far off on a tangent. And so if I type set, we can see that there's all kinds of variables here that are in sort of environment variables. So I'm going to do declare foo is equal to, I don't know, hello. And so now if I do echo $foo, this is really a 200 level course, but this is the only way I could think of to sort of demonstrate what's going on, or this is sort of a 200 level concept, environment variables. The environment variables are things that you can set in your aliases or when you log in or the system uses it, and then you can change behavior of other programs later by checking the environment variable. And there's a lot of stuff going on in the environment actually on a modern system. A lot of cool, neat stuff you can do. So $foo expands into hello, and so when I do the echo, because of the whole environment variable thing. So if I do echo double quote foo, I still get hello, single quote, and I just get foo. So that is why I would recommend in general that you use single quotes when you mean for the shell not to expand things. It works fine with double quotes with find. Somebody probably knows, like there's a bunch of super advanced Unix nerds taking this introductory course, and they're like, yes, I will explain to you why that is the way that it is. And it seems like I used to know once, but I think I've forgotten, because I know that on some systems that definitely Moby star would be expanded with a double quote system. And I'm not sure if it's down to the system or the command interpreter. Probably the command interpreter. But no, I mean, I've been doing this for 20 years. So you as a student, you as a learner, should not be like super freaking out. That's like, how am I going to remember all this little minutia, this little stuff? If you're ever not sure of yourself, you can do little experiments at the command line with Echo or with other little programs to make sure that you're not about to do something bad. You always have to do what's what I call a sanity check. You're just going to check and make sure that the way that you think it is actually the way that it is. And then it helps cut down on errors and mistakes and all sorts of things. So if we do find .-name Moby star, knowing that find itself can deal with wildcards, it's a little bit of an exception to the rule that I mentioned earlier. There are some programs that have exceptions. And then we can see now both of our files are matched correctly. We've got, Moby foo and Moby whatever. Find actually has a lot of options. You can do find files of a certain type, find files with a particular extension, find directories only and ignore the files, find files with a certain permission. There's all sorts of things that you can find. You can even do find dot, which will find everything. We saw that earlier. Grep something, which is a search program. So grep Moby. And that also works as well. It's like find.grep Moby, but notice that we didn't have to do a star with grep. Grep just runs with Moby. And if I do star, it does the whole shell expansion thing again. And if I do grep Moby star or Moby quote, it's still handled in a very similar way. But grep does matching in such a way that I could just say find.grep Moby, and I don't have, whereas find.-name Moby doesn't find anything because there's nothing named exactly Moby. Again, very subtle difference, but very important to understand what's going on here, because grep behaves a little differently. And from our little redirection exercises that we did before, you should understand what's happening under the hood there. Find a dot. It's standard out. It's getting that huge list of insanity. It's just an unwieldy mess. And you're sending it through grep. You're sending it through, basically the selective chipper shredder. And so around the system, there's all this sawdust and insanity from where it had to destroy everything except things that contain Moby. And so that is a different situation than having just find the things for Moby. So find.-name Moby is insanely way more efficient than find.grep Moby. Again, very important, subtle thing to understand. If you want things to run quickly, or you need something for efficiency, or this is inside a loop or something in your system administration, you need to be aware of these kinds of things, because these kinds of things can be real productivity killers as far as doing something inefficient with the system and searching for text and all of the minutia around finding and managing your files. So, very important. So let's do find.egrep Moby. Works basically the same. Man egrep. Manual page, line 1. And the end 644 lines. This has a 644 line man page. So egrep, grep, egrep, fgrep, rgrep. Print lines matching a pattern. It's so like I love man pages that have, it's like name. It's like print lines matching a pattern. That's what it does. But that's like saying the Titanic is a ship or Saturn is a planet, and it's like, well, okay, but I mean, yeah, but it's got its own gravitational field, and it's like on the edge of our sensor radius from Earth, and it is a fantastically huge and complicated program. It's like, what is the difference between grep and egrep? And it's like, well, on most systems, egrep is grep, but grep stands for GNU Regular Expression Program. And so again, we're back to regular expressions. Entire books have been written on just grep, using grep, recipes, a cookbook for grep, all sorts of stuff. And you should definitely read and check that out if you're into finding things. GNU Regular Expressions are a way of shorthand abbreviating things to build something that the computer can use to search strings for, basically. And so you could create a word where you substitute the vowels with numbers, like elite speak or whatever, and grep through and find that. You can also grep through log files looking for IP addresses, grep through the file system looking for permissions. Grep is a fantastically useful search program that is insanely customizable if you can learn a little bit about regular expressions and how to do regular expression searching. And regular expressions are so handy that they show up pretty much everywhere. There are programs for Windows that use regular expressions. A lot of Mac programs use regular expressions. And if you are able to move your way around regular expressions, there's really a lot you can do on a lot of different systems. Going into regular expressions in detail for this introductory course is a little out of scope. So I would encourage you to read more about regular expressions and all of the stuff around regular expressions, but we're going to cover regular expressions at a very basic level right now. So let's say that in Moby Dick we're looking for a word that's SP any character T. So spot, I've just typed SP dot is match any character T. And so if I hit enter on that, and then I do N for next to find the next thing in VI. So there's spite, hospitalities, there's spit, dispatched, respite, hospital, spot, spat, spite, hospitality, hospitable, spot. You get the idea. There's a lot of fun stuff in regular expressions. There are a lot of special characters and matching and that sort of thing. You might hear the term back references and that sort of thing. So maybe we want to match. Let's see. Let's do sp.t \s. So this will match any white space character. So spot, life spot, 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 spote, spot, spot, spit, spot, spat, spot, despot. So we're matching the space now. Maybe I want to do sp.t. Maybe I want a dot, a literal dot. Maybe I want two characters. Maybe I want to do \s or \dot. So I'll show you a website real quick called vimregex. Vimregex tells you a little bit about regular expressions in Vim and the different kinds of characters you can escape and spot. And so we're searching for the word spot. We're trying to spot some useful stuff with this. Spot. I don't have the word spot in there. It's ode to Data's cat. I don't know. It's fine. So you can see that with regular expressions you can create a lot of different patterns, even just beyond the dot. Maybe we want to search for a character. Let's jump to the beginning of the text and then search for any digit. Alright, so 1836 is the first year that appears in the text. Press enter and then N for next, 1839, 1833, 1750, and 1788. 1820, 1839, 1776, 1850. So real easy way to find years there. Maybe we would want to search for, \d, oops, \d7, \d. And so this will find any year in the 17th century. So regular expressions, I mean, this is really not a proper introduction to regular expressions at all, but this should give you an idea of the power of regular expressions, because we've just been sitting here, screwing around with regular expressions, and it's like, I want to find years, I want to find this, I want to find the other stuff. Regular expressions are super, super handy. Although you should note that regular expressions are not super useful for searching for strings or doing validation on things like languages that are not regular, like HTML, XHTML, XML. If you're trying to make sure that you've got an open or close tag, or trying to do a validation, or search and replace, something like that, because HTML, XHTML is not regular. It's not a regular implies that there are certain rules, there's certain lexical rules for whatever it is that you're operating on. Regular expressions do not work on things that are not regular. So keep that in mind before somebody tries to shove a regular expression down your throat. Now, there is one interesting thing that I will show you. Suppose you're a programmer and you need to validate email addresses. The standard for email addresses is a regular expression. They provided the regular expression here for validating email addresses. And this is I mean, look at this regular expression. It is completely unreadable. This is a block diagram of how that regular expression breaks down. So it's like the first character can be one of, and then you've got some higher characters here, and then and this is everything to the left of the @ symbol. So you can have in many of these. Like the first character can be this, but then the second character can be some of this other stuff, and there's stuff in between. And then you get the @, and then you've got one of all of the other stuff. And so this regular expression, if you think about it, if you need to validate an email address is valid, like that the formatting is valid, not that the domain name exists or anything like that, this is an insanely compact way to verify that an email address is valid. And this is a regular expression. This is from the original official standard RFC 5322 for email. And so anything that matches this regular expression basically is defined as a standard email. Now, there are exceptions in edge cases and that sort of thing, but yeah, that's what this is. And that's how insanely powerful regular expressions can be, and why you see them everywhere. And believe it or not, regular expressions are simple as they can be to solve the problem that they're solving, but without being any simpler. And so that is why they are as complicated as they are, or as simple as they are, because it literally cannot be any less complicated. People have tried and failed to make it less complicated. And there are some systems that are simpler, but they also don't have sufficient functionality to be used for the things that regular expressions are used for. Regular expressions are just fantastic. So if you really want to put in some extra credit, some extracurricular activities, look at the RFC for how regular expressions are used for filtering an email address, or applied for validating an email address, and understand this diagram of how this thing here that looks kind of like line noise is processed and parsed. And we'll get a lot more into regular expressions in the 200 level course.